Scripture reading this morning is from the book of Job. It's been the last 3 weeks. This is the third week of using this same scripture. It's because I've been preaching a series of lessons on the wonders of God's creation of just a simple thing like water. And it started off from a series of lessons on the God that we worship, his awesome power, his wisdom, his mercy, his kindness, his forgiveness. One of his great attributes is that he is the designer. He designed everything physical, but he also designed everything spiritual as well. And in the course of these lessons, we've been talking about God, talking with Job. God has a little chat with Job because Job and his friends were saying things that they acted like they knew what they were talking about when they really didn't. They were saying, here's what God does, here's what God doesn't do. God finally has enough of that, and he says to Job, "Who is this who darkens the counsel by words without knowledge? Job, you don't know what you're talking about. Now prepare yourself like a man, and I will question you, and you shall answer me. I'll ask you some questions, and if you can give me the answer, then you're wiser than I think you are." He says to Job, "Where were you when I laid the foundation of the earth?" Job knows he was nowhere to be seen when God laid the foundations of the earth. And in this talk that Jesus is having with Job, God mentions water in all of its forms, liquid, solid, vapor, and he uses that to show the power and wisdom of God. God created water. You didn't, Job. Here's part of what I created. He mentions many other things as well. But we've already had 2 lessons on the awesomeness of water, the awesomeness of God's design ability and his imagination and so many things about what water does and is. We talked last week about the physical or the solid state of water and the liquid state of water. There's a couple things that I should have mentioned last week that I thought about later this week. We talked about lightning last week, but we didn't talk about what goes along with lightning, and that is thunder. Thunder is God's attention getter. Thunder's mentioned many times in the Bible, talking about a very impactful thing happening, God working amongst the people. And thunder is actually one of the loudest sounds in nature. I think scientists say that when Krakatoa, the volcano, exploded, it made the loudest sound that ever happened in the world, ever in history. But a close competitor with that is thunder itself. If you've ever been close by when thunder struck, it gets your attention. It's incredible power. It shows God made that. That's how powerful God is. Lightning or thunder happens when lightning strikes. Lightning is an electrical bolt of lightning, but what it is a plasma of electricity that splits the air, and it goes down and splits the air. And as soon as that lightning quits, that air comes back together again, and it claps together so hard that it makes the sound of thunder. And again, it makes us fear and respect the power of God because he created it. There's another thing that I should have mentioned last week, and that is steam. We talked about, well, actually, I should have mentioned it 2 weeks ago when we talked about water vapor. We talked about the whole vapor cycle, how the oceans evaporate and water goes up into the sky and then gets blown over and dumps water making the rivers and streams and the snowfall and all of that stuff. We talked about water vapor just naturally evaporating. Steam is also natural, can be. It is natural. We can do it artificially too, but it is different than just evaporation, where water just evaporates into the sky without any additional heat. Steam happens when water is subjected to great heat. And what happens on Earth is that there's things, several things actually, that create steam. One of them shows itself in what we call steam vents. These things just show steam just coming up out of the ground. A lot of times it's around volcanoes, but it's not just volcanoes. It can come from other places. But steam is superheated water that evaporates with high heat and high pressure. And where this steam originates is way, way down in the earth. The earth has a crust. We're standing on the crust as we walk around outside. This building is built on the crust of the earth, and it's pretty thick by our standards. But down below that, it's on fire. It is molten lava. It is hot, really hot. Sometimes there's cracks that form in the Earth's crust as it shifts around, and that water, sometimes water can get down. We mentioned last week, talked about water in the liquid form, that there's more water underground than there is in all the water that we ever see around us, clouds, rivers, lakes, oceans. There's 48 times more water underground than there is above. Some of that water leaks down or leaches down through the crust, and when it hits that hot lava, steam immediately happens. And has anybody that's ever looked at a steam locomotive, it's steam that moves that thing that weighs 50 tons or whatever those trains weigh, and that is power there. And so when that water hits the underground lava, steam is created, and the liquid expands as it creates steam, and pressure forms, and that pressure pushes up back through those cracks and comes out like this as steam vents. There's another thing that happens that we're all familiar with, and that's geysers. They happen because of steam as well. And what a geyser is, how it's different from a steam vent, is there's water being pushed up and belched out of the ground. And as we know, like with Old Faithful, every however long it is, enough pressure builds down below, enough water builds up. Finally, the pressure just blows the water right out of the ground, and it erupts until the pressure is let off, kind of like a pressure cooker, where that thing shakes until enough of it goes away, and then it stops for a while, and then it shakes again when steam builds up in the pressure cooker. That is a geyser. You can't even, I mean, it's hard for us to imagine how much power that it takes to blow that much water straight up out of the ground. That steam has that power to do it. But these things are nothing compared to some of the power that steam has, and that's in volcanoes. Volcanoes have several things that happen to them, one of which is just molten lava being pushed up, and then it just overflows and goes down the side. But sometimes there's gases below from the steam that cause it to bubble up, and sometimes it causes it to just throw itself all over the place, and that is the power of steam. We are all really familiar with this picture, Mount St. Helens, when it blew. What this is what's called a pyroclastic flow. Steam pushes up through the snow it melts the snow and creates mud from the ground underneath it, and that mud flows down. There are 25, well, there's more than that, but there's 25 people right now resting 500 feet below the surface of the ground because they were in the wrong place at the wrong time. When St. Helens blew, they were covered up by a pyroclastic flow, which was caused from the steam. So steam has tons of power, and that steam can be harnessed and used. This steam causes all these things to happen in nature. It also can be harnessed and used by us. And so it shows God's wisdom in planning for our future. Now we're going to get to the new stuff. When I preached this series 6 years ago, we didn't talk about these things we're going to talk about now. One of those things that has to do with water is the tides. We all know that the tides come in and go out, come in, go out. Well, they are caused by the moon and actually the sun to a certain extent, but they're caused by gravity. And what happens is you have the moon over there and it acts by gravity. It pulls on the earth. The ground can't move, but the water can. And it pulls the water and makes a bulge on that side. Well, when it does that, there's an imbalance. And the earth, in the meantime, is spinning. As you can see, the circle up there shows the earth spinning inside that bulge. The bulge doesn't move, but the earth spins inside it. And when it spins inside it, the water bulges away from the moon due to over here, there's less gravity from the moon pulling because of the distance, but also there's what's called inertia. As the earth spins, the inertia causes this thing to pancake out and it makes a bulge on the other side. And the earth spins once every 24 hours. And when it does, each place goes through both of those bulges. And that's why we have two tides. And so there's a lot of complicated things involved with it. Why don't the tides go exactly the same every 24 hours? That's because the moon is circling the earth, and it circles at a slower pace than the earth spins, and it's off by like 23 minutes. And so the tides change every day by 23 minutes. Anyway, it's incredibly complicated and awesome thing. But without these tides, we're going to see what happens. 2 tides per day. Well, so what? So there's tides. Well, let's see so what. Why do the tides matter? Well, for one thing, they provide a reliable, renewable energy source. We have windmills and we have water mills that provide energy. We have all kinds of things that provide energy. But as the tides go back, forth, up, down, if you build a machine, you can harness that energy. It's constantly going all the time, and you can harness that energy, making usable energy for us. But what's probably more important is the tides help regulate the Earth's climate. As the water moves back and forth, it can affect the climate. It can also support global ocean circulation, which we're going to talk about in a minute. And the tides also cleanse coastal waters as the waves come in. It cleanses. It helps stir up the ocean to keep the beaches clean and even help take away the sediment from the rivers that bring dirt down and dump it in the deltas everywhere. The tides can help take that sand and spread it around. These coastal waters, as they're being cleansed, the tides flush out pollutants. junk that gets in the water in the coastal areas. The tides also circulate oxygen. We talked about before how most of the oxygen in the world is produced in the ocean itself. And so the tides can circulate this oxygen, and it also prevents stagnation in the bays and estuaries. If there were no tides, the water would just sit still and eventually stagnate and everything would go to pot. Well, the tides, as you can see, are a stirring pot. They stir everything up by the water going back, forth, up, down, up, down. They stir the oceans and keep it mixed. We have tide pools, pardon me, down here. These tides move the water, bring in nutrients. As the water flows from the rivers and into the ocean, they bring nutrients, minerals, and such like down into the ocean, and these tides swirl it all around. They mix it up. They support fishing and food resources. Without the tides, fishing, the fish wouldn't be able to exist properly. We're going to talk about that a little bit more in a minute, but the tides support fishing and food resources. There's a lot more food that comes out of the ocean than just fish. But also we have tide pools. Anybody that's ever spent time on the Oregon coast or Washington coast, California coast, you can find tide pools, and they're just little pools that develop. They're a little higher than sea level. When the tides come in, they push water into those pools. And if you look in those pools, you'll see things like starfish and all different kinds of sea life in there. If there were no tides, those things could not exist. God has planned for all of these things just by making the tides. Salt marshes are another thing. Water comes in with the tides and flows way in there and deposits salt water, and certain kinds of animals and plants grow in those salt marshes. They could never exist if it wasn't for the tides. These ecosystems form the base of coastal food webs and support the fisheries worldwide. And without them, the whole ocean would become stagnant. Another thing that the tides do, the Earth is tilted 23 degrees on its axis and spins at that tilt. That's what gives us our seasons every year. As the Earth goes around the sun hits the Earth differently because it's tilted. Well, if it was just tilted and there were no tides, it would be wobbling and go out of control. That's just a scientific fact. That's what happened. The tides, because the water distributes differently while the Earth spins, it keeps it tilted at that angle, and that's why we have seasons. Without the tides, we wouldn't have, without the tides, we wouldn't have seasons. Without the Earth being tilted, we wouldn't have seasons. So the tides really are important. They provide a lot, and God created the Earth in this way. He created the moon to be just the right distance from the Earth, so it would pull the water just the right way. If the moon was out further, it wouldn't pull as hard, and so the tides wouldn't go back and forth as much. If the moon was closer, it would pull more water, and the water could just cover the entire Earth twice every day, which obviously we know how that wouldn't be real good for us. So God's wisdom is just incredible, even just in looking at the tides. But there's also ocean currents, which are different from the tides. These currents are formed in a different way, and what they look like is like, if I can get this going, pardon me. Well, this was supposed to be a video, but it doesn't seem to be working. So anyway, all these things swirl, 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 swirl. You can see the swirls all over through the ocean. And these ocean currents are driven by wind. Wind blows across the top. Anybody that's been on Fish Lake in the afternoon, sometime you see how much water gets moved across the top of, even just on a little lake like Fish Lake. Well, that happens on the ocean too. That's why you see all the waves going, is because of wind going across the top. It's also caused by differences in water density caused by temperature and salinity, the amount of salt in the water, the temperature of the water. That has to do with the density of it. And when water gets colder, it gets heavier and sinks to the bottom. When it gets warmer, it can rise up. And so that helps cause the circulation of the currents. And Earth's rotation also has to do with, remember we said the Earth is spinning inside those bulges. That has to do with the currents as well, the tides also, and occasional events like storms or earthquakes. You look at those hurricane pictures and you see how much water they suck up, and then when it hits that bulge, that swell, when it goes over land, you've seen the flooding that it causes, that sort of thing. So that has to do with the currents as well. And what you have is a system where these red stripes represent the water, the warm water. Warm water rises, and so it's at the top of the ocean surface. The blue, the cool water, is down deep. Well, what happens as the water goes up to the polar areas, it gets colder and sinks. And when it sinks, it pushes the water somewhere else. And so that water starts to circulate. And it's just a constant system that's happening. The warm water gets pushed along by the cold water. The cold water gets pushed along by the warm water. And that's the circulation that happens. Part of what makes it hard to track is because there's a lot of land in between, and the land affects the way water gets pushed around in the currents. Well, also there's something that is interesting about water, and that is that it has an abnormal ability to retain heat. Water holds heat better than a lot of other liquids. And because it retains heat so well, those currents that are up on the surface that go through the Atlantic Gulf Stream is one of the famous currents that we all hear about. The warm water goes right by the United States and then goes up and crosses the Atlantic and goes up to the England, the northern parts of Europe, and brings warmer water, and it helps regulate the ocean temperature more evenly. What this does is it allows circulation of warm water up to the polar areas. It also allows the circulation of the cool water down to the equatorial areas where it's warmer, and it stabilizes the marine environment. It keeps things more stable than it would be otherwise. These currents also moderate the Earth's climates. If everything was just all cold all the time here and all warm all the time here on the surface of the ocean, weather would be way different, and it would be more extreme than it is. Why the ocean's current matters? The currents matter because they help water temperature distribution. Like I said, if it's all cold in one place and all hot in another place, it wouldn't get distributed properly. Things wouldn't work very well. It helps regulate the climate. We all keep hearing this phrase, El Nino or La Nina, and that has to do with the ocean currents bringing warm water. When certain circumstances happen, the Pacific brings this warm water up from the equator up north, and it causes, as we know, it causes a lot of change in the weather. The currents act as a conveyor belt for heat. The warm water from the equator moves along up all the way to the north to the Arctic, and then it cools down and the cool water comes back, and it's just a big cycle. The ocean currents moderate the temperature of the earth or the ground, pardon me, the ocean as a whole. By mixing this water, by this cycle happening, the water temperatures don't get to the extremes that they would without the currents. We have more stable climates, makes Earth a more hospitable place to live. We don't have these extreme things. I mean, it's everyone will agree our weather is extreme enough as it is. Without the currents, it would be way more extreme, and Earth would be practically unhospitable. Currents affect nutrient distribution just like the tides do. As the currents flow, nutrients from different places of the earth get taken to other places and it distributes them around. It has a lot to do with marine animal migration. The fish and the whales and a lot of these, they follow the Gulf Stream up to the north and spend time in the Arctic area. And then they will follow the currents lower on the lower part to come back down again. So it affects animal migration. The currents impact the health of the coastal ecosystems. As the water circulates, it keeps everything cleaner and more stable. Just like with the coral reefs, if there wasn't moving water through the coral reefs, they wouldn't even start, let alone last any time. So with all this said, water is definitely unique. And there are at least 20 anomalies about water. And what that means is something that doesn't act naturally, doesn't seem right. We're going to look at just a few. First one is that water is less dense when frozen. We talked about that last week. Water, when it freezes, it floats at the top instead of sinking down. We talked about that last week, what the consequences would be. The oceans would freeze solid if it wasn't for this anomaly, this thing that hardly any other liquids float when they're frozen. And so that is one anomaly. Another one is the high heat retention. Most liquids don't hold heat like water does. Another anomaly is capillary action, which we haven't even talked about, and we're not going to talk about it, but I just want to say that without capillary action, you would not be alive because it has to do with the way blood moves through our system. Last week, we talked about the fact that the blood that's in your veins right now is like 94% water. And if it wasn't for the capillary action in water, blood wouldn't come out through that's why they call it capillaries, the little tiny veins or blood vessels that bring the nutrients and the moisture out to the flesh parts of us. No other liquids don't have capillary action. You put a straw in water and you'll see that the water comes up the straw a little ways without you doing anything else. Just stick the straw in there. That's capillary action. That's a force that water has. Another thing that water has that's unique is its high surface tension. I used to think it was really cool when I was a kid. And my stepdad used to roll his own cigarettes. And so he had cigarette paper, and you could lay a piece of cigarette paper on top of a cup of water and then put a needle, a regular sewing needle on top. And then when the water soaked up in that paper, the paper would sink and it would leave the needle floating right on top of the water. And you think, how can a needle float? Well, it can. You can take a razor blade and do the same thing. It'll float on top of the water because of the high surface tension in water. It doesn't do that in other liquids. Another anomaly is the molecular molecular construction of surface ice. You ever wonder what happens when you skate with ice skates? How you glide? You try gliding on concrete and see what happens. You're going to fall on your face pretty quick. Well, most people think that that's what happens is that the pressure from you standing on the ice, the pressure melts the ice because of compression. That may have a little bit to do with it, but that isn't what happens. What happens, and I don't have time to describe it or really show how, but at the surface of ice, the water molecular construction, the matrix of the hydrogen and oxygen atoms changes, and it's really fascinating if you read about it. And what that causes is, just to explain it in a real simple way, it makes like little marbles across the surface, and as you skate, you're rolling on little marbles of a different kind of molecular structure of water. And so these are just a few. There's at least 20 of these anomalies about water that only water does. It's just incredible when you think about it. This whole thing that we've been talking about for 3 weeks, this whole system of water is a perfectly balanced system. It has to do with the Earth's distance from the sun, how far away the Earth is from the sun, how far away the Earth is from the moon. Those all affect. If the sun was closer to the Earth, it would evaporate all the water out, and you wouldn't have water. It would all be stuck in the sky. If it was farther away, it would all freeze, just like it does in other planets that are far away. They don't have water in liquid form because it's too far away from the sun. The distance from the moon affects our tides, and so with the moon being farther away, problems. There wouldn't be as much tides. If the moon was closer, the whole Earth would be covered with the tides. So that had to be perfect. It had to be just the right distance. And then you have the masses, the weight, the amount of matter that there is in the sun and in the Earth and in the moon. That has to do with all of our gravity, how things that react to each other. That has to be perfect. If the sun was bigger, it would pull us closer to the sun and we'd burn up. Sun was smaller, we'd get farther away, and it wouldn't give us enough heat to exist on this Earth. The spin of the Earth also causes is part of this whole balance system. If the Earth was spinning faster, it would cause one thing. If the Earth was spinning slower, it would cause another thing. And I'm running out of time, so I'm not going to talk deeply about any of these, but the quantity of the water in the oceans, how much water is there in the oceans, that matters. If there was more water, obviously more Earth would be covered. If there was less water, less would be covered. It affects this interconnection of the oceans. If there were distinct boundaries between all the oceans, the circulation couldn't happen. Just like you don't have that kind of circulation in a lake because it can't go from one place to the other. It stays in the same place. Well, that interconnection had to be just right as well. The speed of the orbits of the Earth and the moon, that's part of this intricate system. Any change could collapse the whole system. You change any one of those, the whole system could collapse and we wouldn't be able to exist. Our planet would not be habitable. All these things working together. Is this just an accident? Did this just happen? I mean, there's so many things that had to be just right for us to be able to be here and to exist. What that tells us is that there is a designer. It has to be designed. It's too intricate. It couldn't happen just by accident. But not just a designer, but the designer. It tells us about God. As we look at these systems, these incredible systems, the things that water does, it screams a designer. It screams the designer, somebody who is powerful enough, wise enough, smart enough, imaginative enough to be able to do these things. That is the God that we worship. Next week, we're going to be changing gears from water that we see in the clouds in the daytime. We're going to be changing to things that they only come out at night. And we're going to be talking about the stars, the moon and the stars, the things you see at night, the incredible complication, the incredible magnitude, and many things about the things that God created that are out there in the universe. We're going to talk about that next week. So hopefully you'll all be able to be here and we can continue this discussion about the God that we worship and his incredible design ability. But in the meantime, if you're here and you haven't been obedient to the gospel, you don't have a relationship with Jesus, this song encourages you to come forward and make your life right. Get the forgiveness that Jesus died for you to have and the relationship with him that you can have by being baptized into Christ for the remission of your sins. If you're here and you need to do that, just come forward while we stand and sing, "Do You Know My Jesus?"